Okay, so if you've ever propagated a plant cutting, you know this exact feeling. You've waited so patiently, you've watched these gorgeous, healthy roots grow in a glass of water, and then you move it to a pot of soil, and within days, it just withers and dies. Ah, it is so frustrating, it's confusing, and honestly, it happens to pretty much everyone. But what if I told you the real science behind why they fail is actually fascinating and totally solvable? Let's get to the root of the problem. I mean, we've all been there, right? You see that incredible web of perfect white roots. You feel like you've finally done it. You pot it up with so much care, and then you just have to watch this slow, sad decline. You're left standing there going, what on earth did I do wrong? Well, today we're going to solve that mystery once and for all. We usually blame ourselves. We think, oh, I must have overwatered it, or the roots just weren't strong enough. But the real science, it tells a completely different story. The actual culprits are a bit more complex. We're talking about root suffocation and a fundamental biological mismatch between the world of water and the world of soil. Yeah, you can really think of this whole thing as a common plant tragedy. It's the story of an organism that's perfectly adapted to one world, and then suddenly it's thrown into a totally new one without any of the right gear to survive. But the great news is you can be the one to give it that gear. So here's the absolute key to understanding this. The problem is not that your water-grown roots are weak. Not at all. In fact, they are perfectly strong for living in water. When you move them to soil, you're not just changing their address. You're asking them to survive in a completely alien environment. It's kind of like asking a fish to just, start breathing air. It's just not equipped for it. So let's get into the nitty-gritty science of it. We're going to break down exactly what makes these two worlds so different from a roots point of view and why that clash so often turns deadly. Okay, first things first, we need to completely ditch this idea of water roots versus soil roots as if they're two totally separate things. They're not. It's the exact same genetic blueprint, it's just expressed differently depending on the environment. There's a cool science term for this, phenotypic plasticity. A perfect example is a monstera leaf that grew indoors in the shade. If you suddenly stick that plant in direct sun, the leaf just burns, right? It's not a weak leaf, it's just adapted for low light. The roots are doing the exact same thing. They built a body that's perfect for water, and that body is completely unprepared for soil. All right, so if the roots themselves aren't really the problem, what is? Well, the failure comes from this devastating 1-2 punch that hits the plant the second it goes into soil. A total lack of oxygen and a complete inability to find food and water. Let's break those two down. This is the big one. This is killer number one. We think of roots as just needing water, but they absolutely have to breathe oxygen to survive. In a good, airy soil mix, you've got all these tiny air pockets between the bits of soil. But when we pot up a water cutting, what's our first instinct? We keep the soil really wet, right? To make it feel at home. But all that water floods those air pockets, and the roots, they literally start to suffocate. This is called hypoxia, and it is the number one reason these transitions fail. And just to give you an idea of how big this problem is, get this. Oxygen moves through water about 10,000 times slower than it moves through air. 10,000 times. So when you saturate that soil, you have effectively cut off the entire oxygen supply. Those roots that were perfectly happy in their old home are now stuck in an anaerobic death trap. Now for that second punch, starvation. Out in nature, something like 90% of plants have this incredible partnership with beneficial fungi called mycorrhizae. These fungi basically act like a massive extension of the root system, helping the plant find water and nutrients it could never reach on its own. But roots grown in sterile water, they never form this partnership. They are born mycorrhizal, without their fungal best friends, so they go into the soil totally alone, kind of blind and unable to find the resources they need to live. So it all comes down to this. When you lay it all out, the difference is just stark. Water roots are built for efficiency in a liquid world. They're thin, they're super permeable. Soil roots are built for strength and for partnership. So you can see, this isn't just a simple move. It is a complete system overhaul that the plant has to pull off while it's under an incredible amount of stress. Okay, enough of the doom and gloom science of why things fail. Now let's talk about the solution. We're going to walk through a really simple 4-step plan that's based on all this science to give your cuttings the absolute best chance of not just surviving, but actually thriving. These are the 4 pillars of a successful transition. It's actually pretty straightforward. We need to make sure the plant is ready for the move, build it the right kind of new home, give it water in a totally new way, and control the air around it. If you can get these 4 things right, I promise you, you'll flip your success rate on its head. Let's start with step 1, maturity. I absolutely love this quote because it's so simple and so effective. Wait for the roots to have roots. Don't just get excited when you see those long, stringy primary roots. You need to wait until those roots start growing their own little side branches, what we call secondary roots. That is the clearest sign you can get that the root system is strong enough to handle the shock of a transition. So what does that actually look like? Here's your benchmark. You want the main roots to be at least 2 to 4 inches long. That's about 5 centimeters. And this is the important part, you can clearly see smaller roots branching off of them. Hitting that milestone is your green light. It means the plant has enough of an engine room to survive the shock. Next up, step 2, and this is arguably the most important one of all. You have to engineer the right substrate. That's just a fancy word for your potting mix. Your #1 goal here is to fight off hypoxia by creating maximum aeration. You want a mix that is chunky, fluffy, and almost impossible to overwater. A fantastic starting recipe for a lot of houseplants is just equal parts of cocoa coir, perlite, and a decent potting soil. That combination creates all of those vital air pockets we were talking about. And a few more critical tips while you're potting. Use a small pot. A giant pot full of wet soil is just an anaerobic swamp waiting to happen. And please, whatever you do, do not add a layer of rocks at the bottom for drainage. That's an old myth that actually makes things worse by raising the water level and making root rot more likely. And finally, to solve that mycorrhizal problem, you can actually buy mycorrhizal fungi inoculant online or in garden shops. Just mix a little into your soil and you're giving your cutting that fungal partner it so desperately needs. All right, step 3 is all about how you water, and this is a 2-part strategy. For the first 1 to 2 weeks, let's call it the acute phase, you need to keep that super airy mix of yours consistently moist, not soaking wet, but moist. This is to support the old water roots while they figure out what's going on. But then comes the most crucial part. After about 2 weeks, you shift into the adaptation phase. You start letting the top inch or so of the soil dry out between waterings. That little bit of mild stress is the trigger that tells the plant, hey, it's time to build some tough new soil roots. And finally, step 4, humidity. Look, a plant with a new, struggling root system just can't pull up enough water to support its leaves, especially in dry air. So to stop it from wilting and dying, you have to reduce how much water it loses from its leaves. The easiest way to do this? Create a little mini greenhouse. Just put a clear plastic bag or a plastic dome over the pot. Then, over a few weeks, you gradually open it up more and more to acclimate the plant to the normal air in your home. So, you followed the plan, but you're still seeing some signs of stress. First of all, don't panic. Let's really quickly go over what to do, and then I'll give you one advanced tip to level up your game. Okay, here's a quick guide to what the plant is telling you. If the leaves are wilting, it's losing water too fast. Get that humidity dome back on, stat. Seeing a couple of yellowing leaves at the very bottom, that's often just normal dieback. The plant is sacrificing old growth to fuel new roots, so just keep an eye on it. But a mushy stem, right at the soil line, that's the red alert for hypoxia and rot. It means your soil isn't airy enough and you might need to unpot it and add more chunky stuff immediately. And for those of you with really fussy plants, or maybe something particularly valuable, here is a pro move. Instead of going straight from water to soil, you can add an intermediate step. Try moving the cutting into a soilless medium like leca, which just stands for lightweight expanded clay aggregate, or even just pure perlite. This gives the roots that physical structure they crave while keeping oxygen levels super high, making that final move into soil so much easier. Okay, so let's just quickly recap the absolute most important things to take away from all this. First, there's really no such thing as a water root. There are just adapted roots. Second, the real enemies here are suffocation, hypoxia, and the fact that the roots are missing their fungal partners. Third, your secret formula for success is just maximum aeration plus phased acclimation. And finally, if you only remember one single thing from this entire explainer, let it be this. When in doubt, make your soil chunkier. So that really brings us to the end. We've spent all this time focused on that hidden world under the soil, but this whole principle of adaptation, it applies to the entire plant. The light it gets, the humidity in the airflow around it, those are all environmental signals your plants are constantly reading and responding to. So the next time you look at your plants, try not to see just a static green object. Try to see a dynamic, living thing that's constantly trying its best to adapt to the world that you've created for it.